Hey everyone, I want to start talking about bags and blocks. We've done this in class a little bit, but I believe we used bags and bagels, same idea. And we're going to make connections between this, how to write expressions, how to write equations, and then that's going to lead us into using algebra tiles, what they represent in terms of bags and blocks. So you have kind of a connection between the abstract and something concrete. And the whole purpose of everything we're doing today is to get us to understand how to combine like terms and how to use the distributive property. So that's going to be more than one video, so I'm going to break this up into smaller chunks, and then you will be able to watch whichever ones you need. So let's go back and remember what I'm talking about when I say bags and blocks. So if you remember, we have bags here. So let's say that I have 3 bags. You don't know how many blocks are in each bag. But let's say I also have blocks in front of each bag. So let's say let's make 2 blocks in front of each bag, okay? So I have 3 bags, and each bag has 2 extra blocks in front of it. Now you don't know how many blocks are in each bag, so we're going to call that X. So obviously you know I want a let statement first. So we're going to write let X, where's my equal sign, equal the number of blocks in each bag. Okay, so there's my let statement. And I'm telling you that X is representing the number of blocks in each bag. Now, how do I find the total number of blocks in this picture that you see here? Okay, that would be, and I'm just going to do that let statement for you. So let 3x plus, I'm having trouble finding my addition sign here, plus 2, 4, 6, so plus 6 extra blocks. So that's going to be the total number of blocks. Okay? So there are my 2 let statements. So 3x plus 6. I got that because I have 3 bags. There are x blocks in each bag. So to figure out the total number of blocks in just the bags, that's x, which is the same as 3x. And then I have the extra blocks, which all these extra blocks, it's 2 plus 2 plus 2, which is 6 extra blocks. So the total here is 3x plus 6. That's how I got that. Okay? Okay, here we have another example of the bags and blocks, so we're going to call this example 2. What I want you to do is look at the picture. I want you to write me an expression for finding the total number of blocks in this picture. Take a minute and do that. Okay, so the second part of this that I want you to complete, so let's call writing the expression part A. And now for part B, I want you to write and solve an equation if there are 52 total blocks. Okay? Okay, so the next thing that you need to know is we're going to make a connection now between this bags and blocks idea and how to use algebra tiles. So if you remember from the first example I did with you, the bag, that's not what I wanted to do. Let me see, hold on, I don't want that color. The bag, we said, had X number of blocks in it. Okay, so the bag is representing X. It's an unknown. We don't know how many blocks are in there. But the extra blocks, and that's what this blue tile is representing, those were the extra blocks. That was just representing 1 block. So this is just representing 1 block. Now, I want you to remember that because on the next slide we're going to make some connections. So when we use algebra tiles, we use an algebra tile that's a long rectangle, like the one I'm moving around right now, and that's representing our x. And notice it's green because it's representing a positive x. If I were using an x value that was negative, this long rectangle would be red. So essentially, our unknown or our variable that's just an x is going to look like a long rectangle. If we had more than one variable, we'll get into that later on, but each variable has its own algebra tile. Okay, so we'll get into that kind of in a minute, but we're going to stick with x for right now because we're just starting. Now these extra blocks that we were talking about, they kind of look the same as how I did them in the video so far. So these small tiles, these small squares, are representing those extra blocks, so just the number. So each one represents a positive one. Now in this video, I'm going to use green tiles. In class, the tiles we use, the positive ones are white. So different videos might show different things, but just remember what the sizes are, the shapes, and what they represent. The color is kind of insignificant. All you need to remember is that red represents the negative value of that. Okay, so the last tile that I'm going to show you right now is the tile that we use for x squared, and that's going to be a larger square. And in my video right now it's green. The tiles we're going to use in class might be blue. But what you're going to notice, what I'm going to show you, is that the size of x squared, because the length, I'm a little off here so bear with me, the length of this large square is x, and the width of it, the width is also supposed to be x. I guess I was a little off when I made these. I apologize for that. But anyway, the length of this larger tile is the same size as these x tiles. Okay, so it's the same size as this x tile, and the width is also the same. So we know x times x makes up x squared. So you're going to be seeing these larger squares that represent x squared. These long rectangles represent x, and the small tiles represent 1. Okay, so here what you see is we're going to start using algebra tiles. So I have pictured here both the positive values of the 3 tiles I showed you, which are right here. And then I've also shown you the negative values in red. So you should be able to move along with me here. Okay, so let's say we had this equation, that expression that you see right here, 2x squared plus 3x plus 2x. You're going to hear us saying a lot to combine like terms. So we want to simplify expressions and simplify equations where we can combine like terms. But what does that mean? What can we put together? So I'm going to use the algebra tiles to show you how to do 2x squared plus 3x plus 2x. So 2x squared means I'm going to take 2 of these x squared. Plus, so that means I'm adding 3x. So I'm going to take 3 x's. Plus 2x, so that means I'm adding 2 more x's. So right here is where you see my equation represented in algebra tiles. Now what can I combine? You can only put the tiles that are the same together to simplify them. So for example, I can keep those 2 x squareds together, but I can't put them with all of these tiles because they're different shapes, they're different sizes, they're not the same. Okay, they're not like terms. But I can put these 3 x's and those 2 x's together because they're the same. That's basically like saying you have 5 bags. You have 3 bags of blocks plus 2 more bags of blocks. So together you have 5 bags of blocks. So when I simplify, I get 2x squared plus 5x. There's nothing more you can do with that at this point. We haven't taught you anything else. Okay, so take a look at the example that I have here, this equation. So I have negative 3x squared minus 5x plus 3x plus 4x squared. So the first tip that we're going to give you is that since you see a subtraction, okay, so you see a subtraction right there, let's just go ahead and use the sa-cha-cha, same change, or your subtraction rule to make that into an addition problem. So we are going to change that to addition. And the way that we change that to addition is we're going to keep the negative 3x squared the same. And then that subtraction is going to change to addition. So 3x squared plus, and we need to do another change. So now that 5x is going to become negative 5x. And we're going to just copy down the rest. So plus 3x plus 4x squared. I am going to change that color because that seems better, easier to see. Okay, so now we're going to use our algebra tiles to show what this expression is. So we have negative 3x squared. So I'm going to take 3 of these negative x squareds. That's what that looks like. Plus, so we're going to add. It's easier to add and then make 0 pairs versus trying to subtract things we don't have. So we're going to add negative 5x. So that means I'm going to use my negative x's, and I need 5 of them. 1, 2, 3, 4. Do I have enough room? 5. Okay, I might have to do it like this. Now we're going to add 3 positive x's. So 1, 2, 3. And we're also going to add 4x squared. So those are positive. So 1, 2, 3, 4. So now what we're going to do is tiles that are the same size and shape we can put together. So what I'm going to do is I'm just going to get rid of these that I didn't use. And what happened here? There were a couple more. Come on. Alright. So let's take a look at the largest tile. So we have 3x squareds. And when I pair them up, one positive and one negative, they make 0 pairs. So these two together make 0. Come on. Where are my 0 pairs? How come this isn't working? So here's another set of 0 pairs, so I'm going to delete those because those cancel each other out. And then these two make a 0 pair, so they cancel each other out as well. Really need to start using my pointer. That would be exciting. So this is what's left for those large x squared tiles. Now let's get rid of or combine the tiles that are the same size and shape. So we have 5 of my negative x's, which I can already tell is going to match up with 3 of my positives, and those cancel out. So I'm going to get rid of all of these. There's got to be an easier way to do this. There's got to be a way to group them. I'm not really that good at this yet. Bear with me. I paused you and that worked. So all I'm left with are these 2 negative x's. So this is what my, let's see, this right here is what's left. This is what my expression simplifies to. So it simplifies to x squared, and that's a positive, plus here I have negative 2 x's. So that simplifies to that. Now if you had looked in this expression and the ones with the same variable and the same exponent, those are my like terms. So I have a negative 3x squared and a positive 4x squared. So just think about the tiles when you're combining like terms. You have a negative 3 You have negative 3 of them and positive 4. Well, you use your addition rules, and that means you have 1x squared left. Well, 1x squared is the same as x squared. Then if you take a look at these, those have the same variable with the same exponent because you're using the same kind of tile. You have 5 red x's and 3 green ones. Well, use your addition rules to put them together, and you get negative 2x. Okay, lastly, before we go, I want you to try one on your own. I have the tiles there. I'm not going to use the tiles, but I want you to combine like terms to simplify the following expression. So you will see that I have an expression here that says 5x plus 6 plus negative 2x minus 7x squared minus 5. So the tiles are there if you need to use them. Remember some of the tips that I've shared with you, especially the sa-cha-cha. I want you to try it, and that's what we're going to start with next class when we go over this.